Hello, friends. We are continuing our study of geometry, and today we're going to be looking more at triangles. I know you're expecting something different. So we're going to start with a quick review of the Pythagorean theorem, which we looked at in Investigation 2 and in Lesson 29. Basically, if a triangle is a right triangle, then the sum of the squares of the two smaller sides is equal to the square of the hypotenuse. And illustrated here, right, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. This also goes the other way, right? So the Pythagorean theorem says if it's a right triangle, then we have those proportions. The Pythagorean theorem converse, right? Remember, con means you switch because cons switch their identity. You switch the if and the then. So the Pythagorean theorem converse says this, that if you have a triangle and if the sides have the proportions of a squared plus b squared equals c squared of any of the sides, right? So the way you do that is you take the longest side and you set it up. Then you end up with, so if you have a triangle where the sides have those proportions, the longest side would be c, so a squared plus b squared equals c squared, then you know that you have a right triangle on your hands. Very simple. So what you're going to see is types of problems where somehow you know about the lengths of the sides, or you're given the lengths of the sides, and then you have to answer the question, is this a right triangle? And so here's how you figure it out. You just see, you put the numbers into this formula and you see. Now here's a question though. What if they're all the same length? Or what if you've got two sides that are the same length and then you've only got one shorter side? You know, well then in that case, you know that it's not a right triangle, right? A right triangle, it has to be able to fit into a squared plus b squared equals c squared. And so if they're all the same length, well, the answer there is it's an equilateral triangle, equal angular. And if you have two long sides and one side that's shorter than the other two, then what you have there is an isosceles triangle, and it must be acute. Okay, so that's how you deal with that. This also brings us then to, well, what if it's not a squared plus b squared equals c squared? How do we know if it's obtuse or acute? So I want you to imagine it this way. Here's a right triangle, and if I take one of these points, right, and so what I do is I drag this top point to the right a little bit. Allows me to make that, right? So notice what's happening to this angle down below. What happens to this angle? That makes it obtuse, right? Because it's more than 90 degrees, started at 90 degrees. And what's happening here? C is getting longer. So if a squared plus b squared is less than c squared, we have this type of situation, right? C is now longer. So c squared is going to be more than a squared plus b squared. Then we know we have an obtuse triangle. But let's get this back to right triangle proportions, something like that. But if I move this top point to the left, then what's happening is C is getting shorter, right? And that means that this angle down at the bottom that was a right angle is now an acute angle, right? That angle is getting to be less. And then as long as C is still the longest side here, a squared plus b squared is now greater than c squared, right? The length of C is decreasing. And so that would be this situation. If that's the situation, then we know that it is an acute triangle. So the way we put this is that in a triangle where C is the length of the longest side, it is acute if a squared plus b squared is greater than c squared, and it is obtuse if a squared plus b squared is less than c squared. Okay, so that's the Pythagorean theorem, the Pythagorean inequality theorem. Inequality, because we don't have an equal sign here, we have less than or greater than. And so again, what if there is no longest side? Okay, well then it must be, if there's no longest side, that could happen if they're all the same length. And in that case, you have an equal angular equilateral triangle. So that's acute because they're all 60 degrees. Or it would be something like this, isosceles. But these two sides are both the same length and those are greater than this. So then it's like, which one do you pick as C? And the answer is you don't. This must be an acute triangle. If this side gets to be more than these sides, then you can apply the Pythagorean theorem, Pythagorean inequality theorem, to find out if it's acute still or if it is in fact obtuse. So some extensions of the Pythagorean theorem. Again, learning more about triangles than you ever hoped to before. But it is really beautiful. Like everything fits together in this perfect kind of way. So thanks for watching. Don't forget to like and subscribe and share.